Driver Drowsiness Detection System. Yogeshwari Rathod. Department of Engineering, Science and Humanity. Vishwakarma Institute of Technology, Pune, India. Abstract: most of the accidents that have been reported in our country is due to lack of concentration of the driver or feeling drowsy by the driver. Fatigue and microsleeping behind the wheel are frequently the cause of major accidents. However, early indicators of weariness can be noticed before a severe scenario emerges, therefore detecting and indicating driver fatigue is still a study issue. The majority of classic sleepiness detection methods are based on behavioral factors, while some are obtrusive and may distract drivers, and others need costly sensors. In this paper, we have designed a driver drowsiness detection system using Python and Dlib models. This method can reduce the number of road accidents. Also, the proposed system does not require any physical contact with the driver, so it is easy to implement. The system can detect facial landmarks, computes eye aspect ratio, Iyer, to detect drivers' drowsiness based on adaptive thresholding. Machine learning algorithms have been employed to test the effectiveness of the proposed approach. Keywords: Dlib, eye aspect ratio, face detection, facial landmarks, HOG, OpenCV. Introduction. The development of technology allows us to introduce more advanced solutions in standard of living. As per the info provided by NHTSA, each year about 100,000 crashes get reported involving drowsy driving. The exact figure would be far more. Facial expressions can offer deep insights into many physiological conditions of the body. There are innumerable number of algorithms and techniques available for face detection, which is the fundamental commencement within the process. Drowsiness in humans is characterized by some very specific movements and facial expressions, e.g. the eyes begin to shut. To encounter this worldwide problem, an answer is tracking eyes to detect drowsiness and classify a driver drowsy. For real-time application of the model, the input video is acquired by mounting a camera on the dashboard of the car and capturing the driver's face. The Dlib model is trained to spot 68 facial landmarks, from which the drowsiness features are extracted, and the driver is alerted if drowsiness is detected. A lot of research is done in the field of driving safety to reduce the number of accidents. Following work was referred to for the study of the proposed system. Kyle, someone in his paper has designed a system that monitors the driver's face from when the car starts. This mainly helps us to completely monitor the driver's eye blinking and observe it continuously. They used a speed control system to check the speed of the car, and the face image of the driver was being checked using a camera which was already fixed in front of him to alert the driver if they slowed down. It contains two parts: working of night vision camera and prediction of eye blinking rate. This research shows the drowsiness detection and controls the accidents from increasing. If the vehicle is found to be speeding, the control system successfully sends information to the speedometer and thus it reduces to the random speed. V. Shrivastava too in his paper has designed a system with the objective to process images produced by monitoring drivers passively and using it to extract facial features and detect signs of distraction. An important feature of the system is real-time analysis for alerting drivers and avoiding accidents caused by distracted driving. The parameter used for making decisions about distraction is pupil. Using perclose to detect distraction. The proposed algorithm is implemented in which current and ideal position of pupil is detected. Gaze is estimated based on the difference between distance from current pupil position and ideal pupil position to eye corner. The algorithm has been implemented considering the frontal face images. The accuracy obtained for the gaze detection was around 75 to 80%. V. Nagrajan 6 in his paper focuses on building a system based on Viola and Jones method. It detects faces of humans in three ways: vertically, horizontally, and rectangular. The system is used to design the camera and thus the points are directed towards the driver's face and monitor the eye closure of the driver to distinguish the fatigue or drowsiness of the driver. The Viola-Jones method is used to segment the face and eye of the person from the camera. Then perclose is used to detect the eye closure. The Ada Boost and Viola-Jones are used for rejection cascading. The present study states the drowsiness in drivers while traveling and which is the major cause for the accidents. In this paper the concept of Viola-Jones method is used. The eye closure is having three states: open, closed, partially closed. If the driver's eyes are closed means the alarm/warning signal is given to the driver. A. Components. B. Facial landmark marking chart, scatter chart description automatically generated. C. Algorithm diagram description automatically generated.